those look a bit more difficult. I think I'm going to start at 20. So question 20 is the average weight of 4 sacks of carrots is 18 kilograms. If 3 sacks weigh 17.5 kilograms each, what is the weight of the 4th sack? All right, so this is number 20, right? Number 20. I'm seeing like a 28 here. Scroll past, okay. Yeah, so looks like we had some trouble on this question. I will go over this one quickly. So the way we solve it, we can solve it by first seeing what information we can use. So first off, let's see if my pen wants to work. All right. The average weight of 4 sacks is 18, which means if we take all of the 4 sacks together, I'm going to pretend these are sacks, all of them together equal 4 times 18. So altogether they're 72 kilograms because the average is 18. So that means on average, each of these are 18, meaning it's 72. Now, from this, we know some of them are 17.5. And so it's asking what this last one is. So what we can do is we can subtract, this is like 17.5 times 3, because you know, 1, 2, 3. And this plus something else equals 72. 17.5 times 3 equals 52.5 plus something equals 72. Meaning in the end, we just do 72 minus 52.5. Because if something else add the 72, then 72 minus one of them will get the other, and this way as well. And then the answer to this would be 19.5, I believe. Right? Yes, looks like 19.5. Yeah, so the correct answer should have been 19.5. A lot of people had trouble on this one. Actually, did anyone get this one correct? Yes, one person did. But yeah, 19.5 for the first one. I'm just gonna continue going down the word problems. It looks like we did somewhat fine on number 21. Yeah, 21 looks fine. 22. All right, I'll go over 22. For question 22, Mrs. Oswald made some cookies. 1/3 of them were butter cookies, 2/5 were cherry cookies, and the rest were chocolate cookies. There were 30 more cherry cookies than butter cookies. How many chocolate cookies were there? So let's start off by finding the relative amounts of each cookie. So we have 1/3 butter. And then we have 2/5 cherry. Now, I also want to solve how many chocolate there are, but first we need to make these two like denominators, okay? Because that just makes it easier to work with. That should be like the first step whenever you are approached with a problem like this. You should make some like denominators to make everything easier. So what we do for that is we find the least common multiple, which is 15. And then we would end up with 5/15 butter cookies and 6/15 cherry cookies. Wait, no, not 6. My bad. Wait, it is 6. Okay, never mind. Yeah. So, that means butter and cherry cookies total to 11/15. And because chocolate is the rest, okay, so 15 is the least common multiple, but I think the answer is different than 15. So 11/15, so we get 4/15 for the chocolate. Actually, I'll put it here to keep it in line with the rest of the 15ths. Yeah, so once we get this, we see there are 30 more cherry cookies than butter cookies. That means that 5/15 and 6/15, because it's cherry to butter. The difference is 1/15. And that difference of 1/15 is equivalent to 30 more cherry cookies. So if we know 1/15 is 30 cookies, and we know chocolate is 4/15, then we can figure out by multiplication that there are 120 chocolate cookies. That should be the answer. Yeah, 120 is the correct answer. Next question, we had some. $23 looks for the most part, 23 looks good. So I think I'll skip over that. 24, we had, wait, I had 24. 24 looks good for the most part. 25 looks, yeah, 25 looks very good. Most people got those answers. 26 should be, all right, I'll go over number 26. So for 26, we had Mr. Bodie mixed 3 cups of flour with each cup of milk to make pancakes. If he used a total of 24 cups of flour and milk, how many cups of milk did he use? So this is a ratios problem, right? So if this is a cup of milk, he used, this is really crooked actually. And this is a cup of milk, this is a cup of flour, because it's 3 cups of flour to every cup of milk, which is 1 basically. If you use a total of 24, how many cups of milk did you use? So the way we're going to solve this is we can consider this entire thing as a unit, right? So let's just say this makes 1 unit of pancakes. I'm not really sure what a unit of pancakes is, but we know that every unit of pancakes is made by 3 cups of flour and 1 cup of milk. And so if we know he used 24 total and there's 4 here, that means he did this 6 times to get 24 total. So if he had 6 units of pancakes, basically, that means that there were 6 cups of milk as well. Because if once again, just repeating, if there's 24 total, that means he had this ratio happen because there's 4 here. He had to happen 6 times because 4 times 6 is 24, meaning that he did milk 6 times. If the question was asking how much flour or how many cups of flour, the answer would be 18, because instead of doing 1 times 6, we would do 3 times 6, comparing flour to milk. Next question, everyone got 2 to 4 to 3. If only had a 54s and some 45s. Interesting. 29B looks correct. 30 is 5 to 3 to 4. 31 is okay, I'll go over question 31 because it looks like we had some trouble on that one. All right, so this is a 2-part question here. Allie's money is 3/5 of David's money. What is the ratio of Allie's money to David's money? So we can start off by seeing if David had $5, like we don't know how much he has, but if he had 5, then Allie would have 3 because she has 3/5 of his money. Oh, that's much, whoops. Yeah, so why did I get rid of so many? I have to redraw them all. So the ratio of Allie to David, their money is 3 to 5. I'll write it up here actually. Or you can write it like this. So either of these work really. I think we went over like different ways to write ratios. But yeah, part 1 is pretty easy. It's 3 to 5. I think everybody got part 1. Part 2 was a bit more difficult because then we have to figure out what if David gives half his money to Allie? Well, to solve this, we're just going to take half of his money, which is like this much, right? And then we're going to drag it, basically. We're basically going to drag it up to the top. I'm going to see if I can do that. No, I can't. All right. But yeah, I'll just draw out what it would look like. So this one would be cut in half. And then we would take the 2 boxes here. They want to get selected? No, they don't. All right. Guess not. Yeah. So she would have 3 to 5 right now. and David would lose 2.5 because that's half of his money, and so he would lose 2.5, while Ali would gain 2.5. Like if you want to visually represent it, and so she would have 5.5 now, while David would only have 2.5 now. But as you can see here, we're working with fractions, which are really annoying. So the easiest way to solve this is by identifying, once you reach the second step right here, when you realize that you have to cut David's money in half, and you then realize, as you can clearly see, this box right here gets cut in half, which is really inconvenient. So what we're going to do now is you can realize that you can double the amount of both of them to make the math easier. So instead, now Ali is going to have $6 because this is just an easier number to work with. As you do more questions, this will come more naturally to you. And David will have $10 now. It's the same ratio. Like notice how it's 3 to 5. Now it's 6 to 10. We basically just took everything and multiplied it by 2. And then we take half of David's money, which is much easier now that we did multiplied by 2. We take 5 and then we move it over to Ali, meaning now the ratio is 11 to 5. So yeah, the answer would be 11 to 5 for this question, which quite a few people got wrong. Question 32, it looked, we got 9 here, we got 9 here, we got 15. All right, so I will go over the last 2 questions, which are both geometry questions. We did not do much geometry. We didn't do many geometry questions, to be fair, but I still want to go over these. So the first question is we're looking for the area and the perimeter of a shape, which I'm going to send. So first, let's solve the area. So the way we solve the area is we break the shape into 2 sections, which they've already done for us. Those sections are a rectangle and a right triangle. The rectangle is easy. You just multiply the base into height. The base here is 10 because it's the same, because this 10 is the same as the 10 down here. So yeah, it's just 10 times 20, meaning 200. On this triangle, what we're going to do to make it easier is you're basically just going to turn it in your mind. You can just turn it. And then once you turn it, you can realize that 12 is the base and 16 is the height. And so this is base height times 1/2. The reason we multiply it by 1/2 is because a triangle you can just think of as half of a rectangle, right? So we're doing the rectangle formula, but then we're taking half of it for the triangle. And so we do the rectangle formula, and we would get 16 times 12, which is 100. Give me a sec. 192, maybe? I think it's 192. Actually, let me check that. Just want to make sure I got that correct. Yeah, it's 192, just making sure. Yeah, so it's 192, and then we divide it by 2, getting 96. And so we add these 2, so the area is 296. Now, that, of course, is just step 1. Step 2 is finding the perimeter, which should be easy. So once we figure out that this is a rectangle, you know this is 10. And so we just add all the outsides. We had 12, we had 10, we had 20, we had 10, and we had 16. And then all the sums to 58, I believe. Yeah, wait. No, 68. Yeah, so the area would have been 296, while the perimeter should have been 68. Yeah, we definitely had some trouble on that one. Yeah, so for now, we're not doing any crazy geometry. We'll do that. We'll do more complicated geometry later on. For the moment, all you really need to know is just like a triangle. Any triangle is really just like half of a parallelogram / rectangle, depending on like the circumstance. But yeah, I'm just gonna quickly run over that one more time. So for any shape where all its sides are like parallel with the opposite sides, like when so these 2 lines are parallel, meaning that if they extend, they'll always like be like, you know, they'll never touch because they're like, it's like railroad tracks basically. And these 2 lines are the exact same thing. Once you identify a shape as like a parallelogram, such as this, you can just do the base multiplied by the height. So you multiply this number here, which is like let's say 8, and then this, which is maybe 8. And you can realize that this is the same thing as dragging this part over here, making it to here. I'll draw a better example, actually. So if we have this, we have this. So this is a parallelogram. And so what I'm telling you to do is base times height, because this is the same thing as a rectangle, right? You can just move it over and you can visually see how the rectangle is just base times height. And that's just because of the area here. Let's just say, for example, that this is 2 and this is 1. We can clearly see that there's it's 2 times 1, because there's 1 unit here and 1 unit here. If we made it more complicated and we said it was, let's say, I still want to make it easy to draw. Let's say 2 by 4. You can clearly see that it's 8, right? And so for a parallelogram, the concept is the same as a rectangle, because a parallelogram is really just like sliding this over. And then for a triangle, the idea is that it's half of a rectangle or half of a parallelogram, because any triangle is really, you can really just say any triangle is just half of a parallelogram or a rectangle. I noticed I'm using those words interchangeably sometimes. I just want to point out the difference. A parallelogram is just a shape where the opposite sides are parallel, meaning once again, they're like railroad tracks. And a rectangle is just a parallelogram where all the angles are 90 degrees. So it's like corners of a room. So a rectangle is a parallelogram. Sorry if that got confusing. Last question in the geometry area. And then we will be moving on to review 1, and then we'll start the next bit with percentage, I believe. So the rectangles P and Q are equal in area. Let me scroll a bit so you can see better. If the perimeter of P is 32, find the perimeter of Q. So how do we figure this out? Well, we're going to solve this like a puzzle, okay? Step 1 tells us that the perimeter of P is 32. That means, since we know this 12 is the same up here because it's, a rectangle, that means these two add to 24. These two add to 24. And if the total thing sums to 32, then that means these two here add to 8. Now, if those add to 8 and they're the same thing, then each one's 4. So by using the second piece of information along with this 12 that they already gave us, we are able to figure out that this rectangle is 12 by 4. If we know this rectangle is 12 by 4, we also know that the area is 48. If we know the area is 48, and we also know that they're equal in area, we also know the second rectangle also has an area of 48. Now, if we know this rectangle has an area of 48, and we also know it has a 6 centimeter base, we can figure out that the side is 8. And then from here, since there's a rectangle, the tops and sides are same. And then we're looking for the perimeter of Q. So we just add this all together and we get 28. So this is more of like a puzzle question, and it's pretty difficult. But yeah, the idea is that we start off by solving the area. We already have the area, so then we can solve a side. So then we can solve the, oh, and no, my bad. We have a side and we have the perimeter, so we can solve for the last side. Then we can solve the area. And since we know they are equal in area, we know the second guy's area. And then from there, you can figure out the perimeter of the second guy. Moving on to review 1. So if you're following along in the book, move over to the workbook now. Reminder that's under class resources, in Google Classroom. Let me scroll down there quickly. Review 1. I think this is review 1. Yeah. All right. That looks good. All right, so I think we had a bit of, I just want to go over one quick thing. A common multiple. Actually, I want to try something. I think there's a tool here that lets me write. That's not it. Let's try this. This is not working. Oh. Okay, so I just want to go over the difference between a common multiple and a common divisor. A multiple is something that, okay, so first of all, what does common mean? Common means that it's shared by the numbers, okay? So if our numbers are, let's say, 8 and 12, all right? A common multiple would be the multiple, it would be a number that they both can fit into, right? Because it's a multiple of them. Common multiples, there are a lot of common multiples, okay? There are infinite common multiples, okay? 24 is a common multiple because both of them can fit into it. 24 fits in, 12 fits in twice, 8 fits in 3 times. But so is 48, so is 96, so is 192. These are all common multiples, right? So when you're asked to find a common multiple, you can really do any multiple you want, but it's recommended in a fraction problem. In a fraction problem, if you have like 2 over 8 along with like 7 over 12, the best solution is to find the least common multiple, right? So there's a common multiple, and then there's also something called an LCM. An LCM, actually, I'll change this to old factor. An LCM means least common multiple, right? The C from here and the M from here. So the least common multiple is what you're going to use for fractions because it's the easiest. You could use bigger numbers, but it's so much work. The least common multiple would be the smallest number that they both fit into. In this case, the least common multiple is 24. And just to go over this again, the least common multiple is very helpful in fractions because that's how you make denominators equal. So if you wanted to add 2 8s and 7 12s, you would put them both over 24. And then you could add them. And in this case, you could also simplify it to 10 over 12 and then into 5 over 6, I believe. Yeah. So that's the common multiple. And then moving into common divisor and slash factor. That is a number that can go into both of the above numbers. We haven't really found a use for this yet, but it's going to come into play later on. So in review 1 for question 1, that's something, the answer, there's a lot of answers that you could have put, but just not an answer like 2, because an answer like 2 would actually be a factor, not a multiple. The other homework questions look okay so far. All right, so for question, I'm moving down to the word problems because that's usually what people have trouble on. I'm going to go over question 22 first. Move over to the workbook. So the ratio of the length of a rectangle to its width is 4 to 3. If the length of the rectangle is 16, find its perimeter. So this is a 2-step problem. First, we can figure out length to width is 4 to 3. And if it's 16, then the width is, because it's multiplied by 4, this is multiplied by 4, we get 12. And so then to find its perimeter, we add these together and then multiply by 2, because if you think about it, it's 16, 12, and so you would basically get 16 and 12 here. And then you would add them all together and you would get 56. Most people got that question correct, but like some did not. So I just wanted to go over that one quickly. 23 looks all good. 24, good as well. So I'm just going to go over the last question and we can move into today's lesson. Just let me open up the workbook again. I accidentally closed out. Hi, Alan. We're going over like the last 2 weeks homework because I know I gave a lot of homework because Thanksgiving and all. So you had 2 weeks to do it. We are going. I've honestly at this point, like I'm on the last question. So I don't think it's very important that you keep track. Wait, what question was it that I wanted to go over? Oh, I just quickly forgot. Was it the last one? I feel like it was the last one. Sorry, I need to reopen this up. Sorry about that. I just lost track of which question I was going to go over. It wasn't this, was it? 24. Was the last question? It was the last question. All right, yeah. All right, so the last question is, the average weight of three containers A, B, and C is 3.2 kilograms. I need to get a good screenshot of this question. All right. Container A is twice as heavy as container B. Container B is 400 grams heavier than container C. Let's find the weight of container C. So, how do we solve this question? First off, we're going to realize that the total weight of all the containers is just like the average weight multiplied by the amount of containers. So it's 9.6 kilograms. Now, I would like to mention that it clearly says grams here, right? So 9.6 kilograms is going to be difficult to work with. So we're going to say no to 9.6 kilograms, and instead we're going to do 9,600 grams because this is easier, right? And so A plus B plus C equals 9,600 grams. We also know container A is twice as heavy as container B. So we can write it's like two B's basically. It's like B plus B. So this is more algebra, which I don't think we've gotten that much into, but we'll do more on that. And then container B is 400 plus container C. So how do you find the weight of container C? Well, the way we would do this is we can start off by kind of substituting stuff. So if we know that A plus B plus C equals 9,600, and we know that A equals B plus B, so we're going to ignore the bottom one for now. We can basically rewrite this. We can take the first two equations, and then we can make it into B plus B plus B plus C equals 9,600 grams. Now, the reason we're able to do this is basically because we took the A here, and we know A equals B plus B, so we made it into B plus B. Now we're going to do this again. This time we know B equals 400 plus C. So we're going to take all these B's, and we're going to replace every single one of these B's with 400 plus C. So we have C plus C plus C, because there's three of them, and then we add 400 plus 400 plus 400. And then we have a leftover C over here, so it's plus C again. I'm just going to rewrite this. It's C plus C plus C. Don't forget this equals 9,600. C plus C plus C, and then plus C again, because there's 4 in total. And then we're going to add 400 3 times, which is 1,200, and this equals 9,600. So what we're able to do from this is subtract 1,200 from both sides, because we can picture this as a scale. Let's draw a scale. We can picture it as a scale. And if they're equal right now, right, if all of this stuff is equal to all of this stuff, we don't know what it is, but we know they're equal. If you want to take 1,200 from one side, if you want to take 1,200 off, then this side would become heavier, right? And so it would fall this way, but we want to make it equal. So if we're going to take 1,200 from one side, we have to take 1,200 from the other side. That's like the basic principle of like simplifying stuff. Move this over. I'll move it down here. Yeah, so now we get C plus C plus C plus C, or we can say 4C is equal to 9,600 minus 1,200, which is 8,400. And that means 4C is equal to 8,400. We divide both sides by 4, which is like the same principle as we did down here. And then we get C equals 2,100, which should be the correct answer. So that question was definitely more difficult. I can't say I really expected everyone to get it. We haven't really gone much into the we did algebra, right, with like variables and stuff, but like this was a very advanced algebra where you also did averages and stuff. So now we are going to move, if I can scroll all the way down. All right, so now if I can scroll past, we are on to part of the total we are on to percentages, all right? Now, percentages, they're basically just, in a way, percentages are just fractions. They're more like decimals and fractions or percentages are all really just different ways of writing stuff. 80% is really equal to 0.8. Actually, I'll move down to write this. Yeah, if I write something percent, we don't know what it is, something percent, that's we've done algebra. I'll write X percent. X percent of something, let's just say 7, or X percent of Y. Let's write X percent of Y. X percent of Y is really just Y multiplied by X over 100. So when X is 100, when you're taking 100% of something, that's really just Y times 100 over 100. We know 100 times 100 is just 1. So basically 100% of Y, or of anything, is just Y times 1, which is just Y, meaning 100% of something is that something, which is, something that you can intuitively figure out. If I tell you to give me 100% of your effort, I want you to give me all of your effort. And we're going to start off with some questions now. See if I can find some good questions. Yeah, we're going to start off with these. Send me the answers in chat. So keep in mind, a percentage is really just like over 100. So 5% is 5 over 100. And then we simplify that to 1 over 20. So the answer to the first one would be 1 over 20. I'll wait for those answers. Good job, both of you. Good job, everyone. I'm going to send the next batch of questions. Give me 1 second. I gotta close the door, actually. So think carefully about what I've said, and then we can figure out the next question. Give me 1 moment. Just have to close something. I am waiting for my answer, and then I'll go over. One more answer still. Go over it in a minute if you didn't get it. All right, so I'll just go over it now. A bookstore gives a 20% discount during a sale. Now, first of all, what is a 20% discount? A 20% discount is a 1/5 discount. Now, the reason I can figure that out is because 20% is really 20 over 100, and 20% discount, that just means, actually, I'll rewrite this. A 20% discount means instead of paying the full price, you would pay the 80% of the price. Or you could say, I pay 80/100ths of the price. Now, saying 80/100ths is unnecessary because, once again, we can just simplify it to 4/5. And if they cost $40 and $15 respectively, how much did you have to pay altogether? Now, first of all, you could solve 40 and 15 individually, but because the same discount applies to both of the items, you could just add them together. So I'll do it both ways just to show how you get the exact same answer. We get 55 if we add them together. So we can solve it separately, right? If we can solve it separately, or we can solve, this is so skewed, I just realized. Sorry, I don't know why it's so skewed. Yeah, so we can solve 40 and 15 individually, or we can solve it in a single thing. Now, in both cases, we pay 80%, which is 4/5. 4/5 of 40 is equivalent to, what is it? It's equivalent to 8 times 4, which is 32, and then here it is 12, so we get 44, and 4/5 of 55 is just 44. So the correct answer would be 44. And the reason we do that is we just turned the percentage question into a fraction question. Now we're going to do some practice on that. Just remember, a fraction is really just a percent over 100. A percent is really just a fraction over 100. I'm going to post practice 4B. I do not, so when you do these questions, write down your answer, not in chat, just write them down on a piece of paper. I'll post the homework doc soon and you can like write your answers there. For now, let me just work on these here. Oh, wow, this looks really bad. Good job, good job. Yeah. So I'm going to post the homework practice 4B.